What is up, everybody? Welcome back to the last ever physics video that I'm doing for the rest of my career. 2018 exam 3. Just finished 2019's version. If you haven't watched that one, go watch it. It's already out. This is the last exam. Hopefully y'all do well in this. And we're going to start off with number 1. It's going to pop on the screen right there. We're trying to find the magnetic field, the center of the circular portions of the loop. So let's get started. Let's just draw what they gave us real quick. So we have that right there, that. I think, no, that's not it. Okay, yeah, let me draw it again. I messed up. Okay, so we're given basically this, that, and then we're given basically that. So we know from here to there is B, and we know from here to here is A. So we have two regions or two sections we're going to be working on. These, we have 1, 2, 3, and then 4. 1 and 2, both of them are going to be equal to 0 because it's parallel to the actual point. So, and we have current flowing along the I right there. So for this one, we're going to be using Biot-Savart's law. Biot-Savart's law, let's write it down. B is equal to mu naught I over 4 pi ds cross r over r cubed. Okay, so now we're gonna split into two sections. So we'll start off with writing everything down. Mu naught I over 4 pi. Then we're gonna do A radius and all that we wrote, ds cross r over r cubed, plus B radius ds cross r over r cubed. And now we're going to plug in the bounds and plug in the A and R and everything. So this is going to be equal to mu naught I over 4 pi. So for the A radius is going to go from, this is going to be our coordinate system right here. For the A radius is going to go from right here. The thing is going this way. It's going to go from 0 to, or I guess this is going this way. I guess it could be whatever, but I'm going to take it from here. We're going to go from pi to 2 pi. We're going to go from pi to 2 pi. Pi to 2 pi. And then ds is going to be r d theta, which is a d theta times r, which is a all over a cubed. Okay? And the direction of this is going to be into the page. And we're adding this from 0 to pi. 0 to pi, okay? 0 to pi, b d theta times b into the page all over b cubed. And that should be it right there. Okay? Now when you simplify this right here, you're gonna get mu naught I over 4 pi 1 over a, and then you have the integrals pi 2 pi d theta into the page plus 1 over b 0 pi d theta into the page. And then after you simplify that, it's going to be mu naught I over 4 pi. And then you have 1 over a pi plus 1 over b pi. 1 over a pi times 1 over b pi, which is equal to mu naught I over 4 pi. And then you take out the pi, is going to be 1 over a plus 1 over b. So the pi's go away, and the final answer is going to be mu naught I over 4, 1 over a plus 1 over b, and everything goes into the page, and that should be the final answer they get for number 1. And that's it, simple and easy. Let's move on to number 2. Okay? Now number 2 is going to pop up right here. Infinitely long wire, current flows everywhere. Find the magnetic field everywhere, and then use the result to calculate B dot dr for the path shown. So let's start off by writing off the formulas that we're going to be using. We're going to use B dot dr is equal to mu naught I enclosed, and then that's the only one we're going to be using. Yeah, that's the only one we need for this one. So let's start off by solving it. B dot dr is equal to 2 pi rb, because it is a circle, and that is equal to the mu naught I enclosed. So in short, B is equal to mu naught I enclosed over 2 pi r. So we have two sections for this. We're going to do r is less than a, which is inside the cylinder. We're going to find the magnetic field inside. So let's start off by drawing it. That's the thing. And then the magnetic field inside. This is going to be r, and this is going to be a. So let's start off by writing off the formula. I enclosed over I total is equal to pi r squared over pi a squared. And then you have I enclosed is equal to I times, pi's go away, r squared over a squared. And then you plug this into that, move it in. So the final answer you get for this, B is equal to mu naught I r squared over 2 pi r a squared. That goes away. That goes away. 1 r goes away, which is equal to mu naught I r over 2 pi a squared. And you can find the directions by using the right-hand rule. And when you do that, the top direction is going to be out of the page, and the bottom is going to be into the page. And that's the I enclosed. That's the magnetic field inside the cylinder. Now we're going to do when it's outside. When it's outside, the I enclosed is just going to be I, because that's all that's inside. So now since you have that, B for this is just going to be mu naught I over 2 pi r. And that should be the final answer for that. And it's going to be the same exact direction, out of the page, into the page, and that is the B for when it's outside the cylinder. So now to calculate B dot dr for that path exactly shown, we're going to take the formula that we wrote up there, B dot dr, and we're going to calculate the path for the A radius and the B radius. So it's going to be mu naught I, and then we're going to plug this in. Since it's inside the sphere, we're going to be using this right here. R is going to be placed with A. It's going to be 2 pi a squared. And then you're multiplying it by dr, which is just the area. So it's going to be, dr is going to be a pi. It's just going to be a pi. And then after that, you're going to do the same thing for the B side, mu naught IB over 2 pi a squared. And then it's going to be B pi. The pi's cancel out. And then after that, and if you want to know how to get the dr, the dr is integral dr is equal to 0 to pi, and then you got r d theta. And once you do it, it's just going to be r theta, which is equal to r theta. So that's how you get the a pi. And after you simplify all that, you combine like terms. You see the a squared and this the b squared. The final answer is going to be mu naught I over 2a squared, and then you got that small a squared plus the small b squared, and that is the B dot dr along to that path. And that should be the final answer. And that is the answer they get, and that's it for number 2. Okay, so we're moving on to number 3. Number 3 is going to be fairly easy and quick. So the question is going to pop up right here. And I'm going to get straight into working it. So the formulas we're going to need for this one, we're going to need force is equal to I L cross B. That's the first one. Then we're going to need V is equal to IR. And then if you want, you can write the integral form. DF is equal to I ds cross B, the integral form of the force. And those are the main equations we're going to use. So we know we're given a V, so let's calculate the current. It's going to be V over R. Now all we got to do is plug that in over there. So now we know force is equal to V over R L cross B. And we know the L we're given is H, so we're just going to change this to H right here. It's going to be H cross B. And now we know the wire and the thing is at a 90-degree angle. So this is going to be equal to V over R HB sine pi over 2, which is just equal to 1. So it really doesn't matter. And we're going to need direction for this. There's going to be X, Y, there's going to be Z, and it's going to be going, the force is going to be going in the X direction, because if you use the right-hand rule, F, B, I, your current is going, let me see. Yeah, your B points downward. Your B points downward, so when you do the right-hand rule, your current should be in the IX direction. So after all that, you're given VH B over R IX direction, and your B is just B naught. That's the magnetic field they gave you, and that is the final answer for the first part, where it says what is the magnetic force on it. That's the first part. Now for the second part, we're going to be using the next equation. I think this is it's not Biot-Savart's law. I forgot the name of this one. Faraday's law is going to be E dot dr is equal to negative d dt, and then you got B dot dA. So we're going to take it negative d dt B, and then the dA is going to be H. Is going to be H times X. Is going to be H times X. And then when you take the derivative of that, it's going to be negative BH dx dt, which is negative BH V, because this is just equal to V. And now since you have that, negative BHV, we're going to set that equal to the actual V. So negative BHV is equal to the actual V. And once you do that, to find that is going to be V, the velocity is equal to V, the actual V voltage, over BH. And that is also going to be in the IX direction. And that is it for number 3. That's all for number 3. And let's move on to number 4. Okay, number 4, 2018 exam 3. The circuit below was put together a long time ago. At t equals 0, the switch is moved to position B. Find the charge of the capacitor for time t is greater than 0. So I already drew out the diagram, and we're going to be solving it right now. I'm going to set my direction as counterclockwise. My current's going to the right because I set my capacitor positive and negative. Current comes out the positive side and goes all the way around. So I already wrote in the formula. These 3 formulas we're going to need. This is Faraday, this is the capacitor formula, and this is the flux formula when there's inductance. It's equal to 0 because it says there's no inductance, no self-inductance. So now we're going to start off with writing the formula. So we're going to start with the formula. E dot dr is equal to negative d dt B dot ds, which is equal to 0. So now we're going to find the E. We're going to start off with the E dot dr. So let's find it. So let's start off from right here is going negative, so it's going to be positive. Q over C. Okay, Q over C, we're going this way, this way, this way, minus I R1. Oh, It's minus IR2 first, but it's the same thing. Minus IR1 minus IR2, and that is equal to 0. Okay, so now since we're given that, let's simplify. It's going to be negative I R1 plus R2 plus Q over C is equal to 0. Okay, and we know what I is. I is negative dq over dt because it's leaving the positive, is getting weaker. So we can substitute that in. It's going to be negative dq, or positive dq now, right? Yeah, it's going to be positive dq over dt, R1 plus R2 plus Q over C is equal to 0. So that's what we have right now. And for this one, we know Q over T. We're going to be using the fundamental equations. AE negative beta T. Or it's going to be alpha E negative beta T. I don't think it's A. It's alpha E negative beta T. Alpha E negative beta T. Okay. Alpha E negative beta T. So now we're going to try to solve for beta, and we're going to try to solve for alpha. So first off, to find beta, let's write that down. Find beta. Oh, okay. We're going to need the dq dt of this. dq dt is going to be alpha negative beta E negative beta T. And then we're going to be substituting this all into this. Okay, I see it now. Okay, so let's get started. We're using this formula. So it's going to be alpha negative beta E negative beta T, and then you have R1 plus R2, R1 plus R2, and then you have plus 1 over C, and you know the Q is alpha E negative beta T, and you know all that is equal to 0. So now you can just eliminate similar things. I think you can eliminate that. E negative beta T, E negative beta T. You can also eliminate the, I think that's all you can eliminate. Yeah, that's all you can eliminate. So once you get all that, the final thing you get is negative beta R1 plus R2 plus 1 over C is equal to 0. And now all you gotta do is solve for beta, which is easy now. So now you know beta is equal to 1 over R1 plus R2 C, and that is the beta. And now you can solve for alpha easily, just using the QT is equal to alpha E negative beta T. All you got to do is negative beta T. Oh, you know beta now. So it's going to be, you already know beta. So it's going to be, let's do that again. You got to plug in the beta. Negative beta T is going to be T over R1 plus R2 C. And we're going to find, we know at T equals to 0, T equals to 0 is going to be equal to CV. So at Q, T equals to 0. There's going to be 0. It's going to be alpha. You know this is alpha, and this is equal to CV because at T equals to 0, the switch is moved to position B, so it's charged at a regular CV. So now we know alpha is CV, and now with that information, we can finally put all this in the main equation right here. So the final answer is going to be Q as a function of time is equal to CV E negative T over R1 plus R2 C. And that should be the final answer. Let me move that so you guys can see it. Let me move it so you guys can see that right there. That right there. Yep. That's the final answer right there. And that's it for number 4. Thank you guys for watching 2018 Exam 3. Hope you guys enjoyed the video. Comment down below if something didn't make sense. DM me on my Instagram. It's at the bottom of the description. Just DM me, follow me on Instagram if you want, have questions. And thank you guys for watching. That's it for the physics series. It was nice going along this journey with y'all. Hopefully y'all benefited. And I'll see you guys in my next video that is not physics. Thank you guys for watching.